Hello everybody, I am here to show our channels, YouTube channels, Mathpositive channels, aim to tell about our contents, our aim to entertain you, to have fun together by maths and geometry. Our contents, as you just check our channel, are about mathematical equations, but not just mathematics. The funny contents are in our channel. Geometry, triangles, rectangles, questions, puzzles. We want to make you have fun when you just surfing in our YouTube channel. Mathpositive, as in its name, aims to show you the positivity of the mathematics. Maths is not just a lesson, a course in school, but it's life. It's in every day of life, every second, every minute of life, and it's just about every day of our daily life. So we want to show you the beauty of maths, the beauty of numbers, the beauty of just these questions and their solutions. We invite you to see our contents. As Mathpositive channel, we are working for your joy, your fun. And today I want to give some examples to you about what we have done, what we do in our channel. Today I want to tell you about quadratic equations. Let's see what is a quadratic equation. A quadratic equations are, let's just show this, are like a times x squared plus b times x plus c equals 0, where a, b, and c are real numbers and a is non-zero. This is a quadratic equation. A times x squared plus b times x plus c equals 0 is a quadratic equation where a is non-zero, b and c are reals. So this is an equation to be solved. We want to solve this. We want to find x value or values which satisfies this equation. Solving an equation have steps. Yes, we want to follow some steps to solve such equations. First step or first method to solve such an equation may be factorizing. First method is factorizing. What does it mean by factorizing? Let me show you what is factorizing a quadratic expression. A times, let me just begin with some simple form of this. X squared plus bx plus c, where a is 1. When a is 1, we can factorize this expression like this. We should find two real numbers, say m and n, so that m times n equals c and m plus n equals b. Repeating this, we should find two numbers, let's say m and n, such that m times n should be equal to c, this our constant, and m plus n should be equal to b, which is coefficient of x term. Then we can write x squared plus bx plus c as x plus m times x plus n. This is a simple factorization. Let's give some example. X squared plus 3x plus 2 to be factorized. Now we need two numbers where their product equals 2 and their sum equals 3. These numbers are 2 and 1. 2 times 1 equals 2 and 2 plus 1 equals 3. Then our expression can be factorized x plus 2 times x plus 1. You can check whether you have done this correctly. Let's check this. X plus 2 times x plus 1. Let's just multiply this two expressions. X times x equals x squared plus x times 1 equals x plus 2 times x equals 2x plus 2 times 1 equals 2. Combining these two expressions, combining these x and 2x, we get 3x, x squared plus 3x plus 2, and that's correct. That's our expression in the question. Let's give some another example. Example 2. Let's have x squared plus 5x plus 6. Let's have this expression. Then we need two numbers. They sum up to 5. M plus n would be 5. And m times n will be 6. These two numbers are 3 and 2. Then we have 3 plus 2 equals 5. And 3 times 2 equals 6. Our expression will be factorized as x plus 3 times x plus 2. One last example. Let's do one last example, which is x squared plus 6x plus 5. If you see, our 5 and 6 have changed their position. We need two numbers. Their products will be 5 and their sums will be 6 this time. 5 times 1 equals 5 and 5 plus 1 equals 6. Our numbers are 5 and 1. Then the expression will be factorized as x plus 5 times x plus 1. As you see, this is not too difficult to factorize. When a is equal to 1, when our leading coefficient equals 1. It's not too difficult. Maybe we see such expressions like x squared plus a plus b times x plus a times b. It doesn't matter whether they are numbers or letters. The method is finding two numbers, their product equals this side and their sums equals this side. As you see, this is the product of a and b, and this is the sum of a and b. So we have x plus a times x plus b. Okay, you see, factorizing is not a matter for us from now on. Ne yapabilirsin? Dur şu anda burayı mı? Let's see some examples from our textbook. This example says 2 times x minus 6 times 5 minus x equals 0. Find the roots. Find the x values which satisfies this equation. As you see, this is a factorized expression, and we should just equal these to 0. Then we will have 2x equals 6 and x equals 3 from this factor, and the other one 5 minus x equals 0, and then 5 equals x. The set of solution will be 3 and 5. Okay, solution of this question is this one. The others, maybe this one, this is some sort of letters. Okay, our question says a and b are reals, a and b are reals, and we have this equation. Find roots. Find zeros. Okay, this is non-factorized yet. We should have factorized this. It is x squared minus 3a minus b times x minus 3ab equals 0. We should find two numbers which products equal to minus 3a times b, and their sum will be minus 3a and plus b. So this shows our numbers actually. This is minus 3a times b, and this term is minus 3a plus b. So the factorized version will be x minus 3a times x plus b equals 0. Then we have roots x equals 3a and the other one x equals minus b. Our solution is like this, and set of solutions will be 3a and minus b for this quadratic equation. Let's move forward. We have a visual question here, a table of like rectangular shape. The x have length x minus 9 and 3x minus 24. Okay, we have x with lengths x minus 9 and 3x minus 24, and the question says the area of this table is 36 units square. 36, then it is x minus 9 times 3x minus 24 equals 36. That the area of a rectangle is the product of two edges. Let's just begin with just distributing these terms and write 3x squared minus 24x minus 27x plus 216 equals 36. Okay, just let's write 3 times x squared minus, combining these two, 51x, and having 36 this side plus 160 equals 180, equals 0. Just dividing by 3, we will get x squared minus 17x plus 60 equals 0, and this is our quadratic equation to be solved. Let's just find two numbers, their products equals 60 and their sums equals minus 17. These numbers can be 15 and 4. No, this is not the case. Maybe 12 or 5. Yes, 12 and 5, which we multiply. If we multiply these two numbers, we will get 60. And if we add two numbers, we will get 17. But our middle term is minus 17. Then these two should be minus 12 and minus 5. Then our factorization is x minus 12 times x minus 5 equals 0. So x may be 12 or x may be 5, which we find from our equation, but x must be 12, because if x equals 5, we will have negative lengths, which is nonsense, which makes no sense. The lengths must be positive numbers, so 5 is not a case for us. So x should be 12 for our question. Let's move forward for some other question. This discriminant method, maybe we should talk about this method, discriminant methods, which is for a quadratic equation a times x squared plus bx plus c equals 0, the discriminant equals b squared minus 4 times a times c. This is the discriminant of this expression, and we have our roots, say x1 and x2, which x1 equals minus b plus square root of discriminant over 2a, and the other one x2 equals minus b minus square root of discriminant over 2a. This is another method which we call discriminant method to find the roots of a quadratic equation. We can use, besides the factorizing method, we can use this method to find the roots. Let's just try this method in this equation, which is x squared minus 3x minus 2 equals 0. Now we can factorize this maybe, but we want to use the discriminant method. So we have a equals 1, the coefficient of x squared, b equals minus 3, the coefficient of x, and c equals minus 2, which is the constant term in our equation. So if we calculate discriminant, which was b squared minus 4ac, we will get minus 3 squared minus 4 times 1 times minus 2. Okay, the square of minus 3 equals 9. Here we have 2 minuses, which makes plus. 4 times 2 will be 8. Then our discriminant equals 17. So our roots x1 and x2 will be minus b plus square root of discriminant over 2a, then minus b equals minus 3 plus square root of 17 over 2 times 1. So 3 plus square root of 17 over 2 is our first root. 3 plus square root of 17 over 2. The other root, x2, may be written as 3 minus square root of 17 over 2, because in our formula just we have plus or minus square root of discriminant. So the other root will be 3 minus square root of 17 over 2. This is discriminant method to find the roots of a quadratic equation. Some other question may be, which one? Some other question may be this example, which says x squared minus 4x plus 5 equals 0. So we have an equation, which quadratic equation. Then we try to factorize this, but 5 is a prime. So 5 times 1 or minus 5 times minus 1 would give 5. But the sum of these numbers cannot be equal to minus 4. So this method doesn't work. Our second method was discriminant method. Let's evaluate discriminant of this equation. Minus 4 squared minus 4 times a, which is 1, times 5. So square of minus 4 equals 16, and 4 times 5 equals 20. We get minus 4 as our discriminant. So writing our roots, x1 equals minus b minus minus 4, which is plus 4, plus square root of discriminant, which is minus 4. over 2a, which is 2. As you see, if our discriminant is negative, we cannot have real roots. Minus 4 square root equals square root of 4 times square root of minus 1. This equals 2, and this one is the complex number I. Okay, my friends, I see you wanna sleep, but doesn't sleep, okay? We have x1 equals 4 plus 2i, over 2, which is 2 plus I is our first root, which is a complex root. The other root of this equation will be 2 minus I. x1 was 2 plus I. x2 will be 2 minus I because of the plus or minus square root of discriminant. We have such roots, which are complex roots. The equation have no roots in real numbers, but have two distinct complex roots. Şimdi duralım. Okay, friends, let's just have some rules about exponentials. As second part of our video, exponentials, as you know, is a times a n many equals a to the power n. As a definition, exponentials can be written like this: the product of n many a's will be shown as a to the power n. Here we call a the base and we call n the power of a. When we see an expression in maths like a number and some other number above this number, this is about exponential. For example, if we have 2 to the power 3, it means 2 times 2 times 2. 3 of this. We will have 2 times 2 equals 4, and 4 times 2 equals 8. This is a simple question. Let's say 3 to the 2, 3 to the power 2, which means we multiply 2 3's and get 9. This is 2. We multiply 3 twice and we get 9. This is the simple expression of exponentials. Let's just have the rules. Multiplication rule of exponentials. Let's have a to the power n times a to the power m. This will be equal to a to the power n plus m. We add the powers and write just as power of a again. For example, if we have 2 to the power 3 times 2 to the power 4, we will have 2 to the power 3 plus 4, which is 2 to the power 7. Okay? The second one is when we have powers equal and base difference, namely a to the power n times b to the power n. Our bases are different, but our powers are equal. In this situation, we multiply a and b, just have the common power n. Namely, as an example to this, we can say 2 to the power 3 times 5 to the power 3. This will be equal to 2 to the power 2 times 5 to the power 3, which is 10 to the power 3. Okay? The two multiplication rules are, the first one is, when bases are equal, we add the powers in multiplication. When the powers are equal, we multiply bases, have the common power to the power. Okay, let's give some example. Let's give some example to this, where 3 to the power 5 times 3 to the power 4 equals x, and 5 to the power 2 times 4 to the power 2 equals y. Let's just apply our rules to this. X will be equal to 3 to the power 5 plus 4, which is 9. 3 to the power 9. And the second one, y will be equal to 5 times 4 to the power 2, so 20 to the power 2. Our rules can be applied like this. Let's call two special powers, which first one is second power of a number, which we just read x squared. When we have second power of a number, we read like x squared. And when we have third power of a number, we read it as x cubed. These two powers are special to say when we say find the square of 5. This means find 5 to the power 2, which is 5 times 5, and it equals to 25. Or when we say find the cube of 3, this means 3 to the power 3, which is 3 times 3 times 3, equals 3 times 3, 9 times 3, that's 27. If some number have power 2, we read it as x squared, and power 3 we read as x cubed. These are special readings of two power. The other powers are just said to have x to the power 4. Okay, x to the power 5, x to the power 6. Just second and third powers are special for us. Let's just move on. The division rule of exponentials. Division rule is, the first version is a to the power n over a to the power m. When we have bases equal, then we just subtract the powers from each other, which is a to the power n minus m. Let's just see some example. We have, let's say, 3 to the power 5 over 3 to the power 3. Then we will just subtract the powers and find 3 to the power 2, which is 3 squared. 3 times 3 equals 9. Okay? If we divide two exponentials with the same base, we subtract the powers and find the answer. The second version is a to the power n over b to the power n. In this version, we have powers equal to each other, but bases may be different, may be equal, but the powers are equal to each other. In this version, we will divide a to the b and have the common power n. Let's see its example. 6 to the power 5 over 3 to the power 5. As we see, the powers are both 5. Then we will divide 6 by 3 and have power 5. If we divide 6 to the 3, we will find 2 to the power 5. And this will be 2 times 2 times 2 times 2 times 2, which is 4 times 4 times 2, and this is 16 times 2, which is 32. Okay, let's check. 6 to the power 5 over 3 to the power 5, which is 6 over 3 to the power 5, and that's equal to the power 2 to the power 5, which is 32 as our answer. The other rule of exponentials is power of the power rule. Power of the power rule, which is when we have an exponential and we want to have some other power of this exponential number, we will multiply these two powers to each other, which is a to the power n times m. In other words, we can write this as a to the power m to the power n, which means we can change the position of these two powers if we need. A to the power n to the power m equal a to the power m to power n. Let's see some example. 2 to the power 3 to power 4, which will be equal to 2 to the power 3 times 4, which is 2 to the power 12. Okay, we multiply the powers when we have power of the power rule. Okay, we can write this as 2 to the power 4 to power 3 cubed if we need. Okay, these two expressions are the same. You can change the order of these powers if you have power of the power. Okay, let's have another example where we want to compare three numbers. The first one, x equals 4 to the power 20, y equals 2 to the power 41, z equals 8 to the power 14. And we want to compare these three numbers, sort these three numbers. Our bases are different and our powers are different. So we have to do something. We have to reorganize these numbers using power of the power rule. Let's just begin with x. If you see, this 4 is equal to the square of 2. Writing this way, we have a power of power question. 4 is equal to 2 to the power 2, and applying our rule, 2 to the power 2 times 20, which is 2 to the power 40. Okay, y is already 2 to the power 41, so we pass to z. If we consider 8 here equals to the cube of 2 to the power 14. Cube of 2 equals 2 times 2, which is 4 times 2, and equals to 8. So 8 is equal to 2 to the power 3. Then applying power rule, we see 2 to the power 3 times 14, which is 2 to the power 42. Just seeing the results, the first one is 2 to the power 40, second one is 2 to the power 41, and the third one is 2 to the power 42. We can say the least one is x is less than y and less than z. This is our result. We compare these three numbers. Okay, friends, we have another question about comparing these three exponential numbers. A equals 8 to the power 20, B equals 5 to the power 30, C equals 3 to the power 45. Let's write this as 8 to the power 2 times 10. B as 5 to the power 3 times 10. And what is C? We can't do that. 3 to the power 9 times 5. This doesn't make sense. Let's have let's have just write 8 as 2 to the power 2 to the power 3 to the power 20, which is 2 to the power 16. B is already 5 to the power 30, and C is already 3 to the power 45. If you consider our powers are all 15 times something, we will use this. A is 2 to the power 4 times 15. B is 5 to the 2 times 15, and C is 3 to the power 3 times 15. The first one can be written as 2 to the power 4 to power 15. Second one can be written as 5 squared to the power 15. And the last one can be written as 3 to the power 3 to the 15. Evaluating this basis, 2 to the power 4 will be equal to 16 to the power 15. The second one will be 25, which is 5 squared to the power 15. And third one will be 27 to the power 15. So we have our powers equal to each other from now on. Then the least one is A, the middle one is B, and the greater one is C. A is less than B and B is less than C is the answer of our question. Okay, let's just find some other question to solve. Here is some good question. Which says, if 3 to the power A equals 2, then find 6 to the power A over A plus 1 equals what? This is the question, which is a very good question. Let's just have let's see what can be done. We need some 6 somewhere, but we don't have. We don't have a 6 to use. We have 3 to the power A equals 2. We have 3 to the power A equals 2. If we multiply this equation, the both sides, by 3, we will get 3 times 3 to the, we will have 3 times 3 to the power A equals 3 times 2. We will have this equation. So, as you see, here is some multiplication of the same base. We have 1 power here. This will be equal to 3 to the power 1 plus A which is equal to 3 times 2, 6. We now have our 6 equals to 3 to the power 1 plus a. Just putting this into this equation, this expression, we will have 3 to the power 1 plus a to the power a over a plus 1. Since this is power of power, we have 3 to the power 1 plus a times a over a plus 1. Cancelling these two a plus 1s, we have 3 to the power a, which is given 2, and the answer of the question should be 2. Very nice question and a nice solution. Okay, let's move forward for some other question. Here is a nice question again. It is 3 to the power 7 times 9 to the power 5 over 27 to the power 2. Let's just write 3 to the power 7 times 9 is equal to 3 squared to the power 5 here, and 27 is equal to 3 cubed power 2. Let's just use power of power rule. Then write 3 to the power 7 times 3 to the power 2 times 5, so 10 over 3 to the power 3 times 2, so 3 to the power 6. We used our power of power rule and find these terms. Let's move forward. The upper side is multiplication of common bases, so we add these two numbers up and write 3 to the power 17 over 2 to the power 6. And this is another rule, division rule with same bases. We can write this as 3 to the power 17 minus 6, which is 3 to the power 11, and the answer would be D. Okay, my friends, this is using our rules, combining our three rules together and finding the solution of this question. Another one is this fifth question. We can solve this. This looks nice. Let's solve this question. It says 2 to the power 11 plus 2 to the power 11. Again, 4 times 2 to the power 11. Let's write this. The upper side is 4 times 2 to the power 11. The other side, we have 2 to the power 8 minus 2 to the power 7. Here we have 2 squared times 2 to the power 11 over, writing this 2 to the power 8 as 2 to the power 7 times 2 to the power 1 minus 2 to the power 7. We will have 2 to the power 13 over 2 to the power 7 times 2 to the power 1 minus 1. So this is 2 to the power 13 over 2 to the power 7, since 2 minus 1 equals 1. And this is the division rule. This is the division rule. We subtract 7 from 13 and find 2 to the power 6, which is again D is our answer. Let's see some another questions. This one may be our last question today. We have X, Y, and Z are real numbers. Let's write. We have X, Y, and Z are real numbers, reals, and we have 2 to the X equals 20. We have 3 to the Y equals 25, and 5 to the Z equals 130. So the question wants to compare these X, Y, and Z numbers, which are our powers in this question. Let's just think about what can we do about this question. If we think about the powers of 2, we will see the first power of 2 is 2. The square of 2 is 4. The cube of 2 is 8. The fourth power of 2 is 16. And the fifth power of 2 is 32. Here in the question we have 2 to the power x equals 20. If we see our table, 20 is between 16 and 32. So our 2 to the x is between 2 to the power 4 and 2 to the power 5. Then we will have 4 is less than x and x is less than 5. We have 4 and 5 as our boundaries for x. Doing some similar operations for the other two, we will have the second one was 3 to the power y equals 25. Let's see the powers of 3. 3 to the power 1 is 3. 3 to the power 2 is 9. And 3 to the power 3 is 27. Since 3 to the power y equals 25, we have 3 to the power y is between 3 squared and 3 cubed. So y is between 2 and 3. This is our second solution. And lastly, we will be doing 5 to the power z equals 130. 5 to the power z equals 130. Let's see the powers of 5. 5 to the power 1 is 5. 5 squared is 25. 5 cubed is 125, and 5 to the power 4 is equal to 5 times 5 times 5 times 5, and this is 25 times 25, which is 625. As you see here, 5 to the power